Hello everyone. Hey, in this little video we are going to go over percent of change. Specifically, we're going to talk about what is percent change, what makes up percent change, how is percent change calculated, and we want to think about the answer clearly, make sure we understand what we're getting. You'll remember in class we looked at percent change using this IndyCar race, where you're asked about the percent change in the average speed for different years. And when we did this, here's the example we had. That is, we wrote this ratio of the speed from 1922 to 1955, and we did that here, and we looked at how much it changed, the change in the speed, divided by or over the starting speed. And we did that same also for 1955 to 2010. And we found that when we plugged in the numbers, the change was the same in both cases. That is, the difference in speed between 22 and 55 was 34 miles an hour. And the difference in speed between 128 and 162, that is these two periods of time, was also 34. But when you go to do percent of change, you compare it to the starting value. In this case, we started in 1922, so we had to compare it to 94 miles an hour. And from 55 to 2010, we started in 55, so we had to compare it to 128. And when we did, we saw that the percent change from 22 to 55, 1922 to 1955, was 36%. And from 1955 to 2010, it was a 27% change. And we noted that even though the change was the same, we divided by a larger number. And when you divide by a larger number, you get a smaller answer. So I'll say it once here. So the percent change described how much the average speed changed compared to the starting year, in this case 1922. Where here, the percent change, 27%, gives you an idea of how much the average speed increased compared to the 1955 average speed. Okay, let's look at, but we looked at it another way. Another way we looked at it, and so here we are. What is percent change? We had a flower, right? And this flower, it started at 5 feet. It's the same flower here, and it grew to 8 feet. And we asked the question, what is the percent change of the flower from 5 feet to 8 feet? Let's write that down so we have the question clear. What is the percent change from 5 feet to 8 feet? I will endeavor to write as neat as possible. Notice very clearly I'm starting at 5 and I'm going to 8 feet. So where I start and where I end matters in the calculation. And so the short definition for percent of change is simply this. So I'm going to write it this way. Percent of change. So here's the definition that we use mathematically that we can calculate. It is the change, that is the change in values. Let me write that down. Change in values from the start to the end over the starting value. That's a little wordier than I wrote in class. So in class we wrote it this way. It's the change over the starting value. So let's consider our case here. So we can see that the flower, it grew 3 feet. That is, its change was 3 feet. This is the change. Want to be really clear. So this change here is 3 feet, and that's what we're talking about here, the change. So, and the starting value was this 5 feet. So here's my starting value. This is my start, and this is my end. So when I go to calculate this thing, I have the change, which is 8 minus 5, that's the change, over the starting value, 5 feet. So let's be really clear here. Once again, this top piece is the change. But percent of change is the entire ratio that we're going to write as a fraction. So the change is on top, but the percent of change is the entire ratio that we're going to simplify and write as a percent. I hope that is clear. It's worth saying one more time. So the top value is just the change, the 5 feet. But the entire ratio is the percent of change. And now we can do the calculating. So 8 minus 5 is 3 over 5. And now I want to write this as a percent. Conveniently, I can get this to 100 in the denominator, because I know that percent means out of 100. So now I have 60 over 100, or 60%. So let's make sure we're clear. What this means is the flour grew and increased 60% compared to where it started. Compared to where it started. So the 60% change, this 60% increase, because it grew, is 60% compared to this height here, 5 feet. And in class, we asked the question, well, what if the change went the other way? So let's go like this. What if the change, so let's find, or let's set up, I'll say, find percent change from 8 feet to 5 feet. Well, the change itself is going to, so let's write it, the change itself is going to be the same. It's still going to be 3 feet, but it's going to be a decrease this time, isn't it? And I'm just going to write the change as change here over the starting amount. In this case, we're starting from 8 feet. So we would have 3 over 8. And I will leave it to the viewer to figure out the percentage here. But we can see that 3 over 8 is definitely going to be different than 3 over 5. So one more time, percent of change is the entire ratio here, simplified and written as a percent. So I just wanted to stress the difference between the percent of change and the change itself. And so going back to where we started, percent of change is this ratio, right? And it's made up of the change over the starting amount. Let's write this. So this piece is the change. This piece is the starting value. And when we simplify the ratio, the whole ratio, we get the percent of change. We did one calculation here, and then we thought about this answer. We thought about, well, what does this 60% mean? It means the flour grew 60% compared to where it started. Okay, let's do one more sample, and we'll take it from the homework, and then we'll call this video done. So I'm just going to use this first problem here. Let me raise this up. So a popular brand of running shoes costs a local store $68 each pair. So the store buys it for $68. If the store sells the shoes for $119, what is the percent of increase? Now here they're telling you that it's an increase, and it makes sense. It's going from 68 to 119. But what is this percent of increase in the price? Okay. I'm going to do the work right here so I can separate it from this work up here. So on my starting value, so it starts at $68 and it ends at their selling price, which is $119. And I want to find the percent increase, right? So the change is simply going to be the difference, 119 minus 68. What's 119 minus 68? Well, let's do the long way, just make sure that we're all following things. So 9 minus 8 is 1, and 1 minus 6 I can't do, so I have to borrow. So 11 minus 6 is 5, so 51. So the change over the starting value, in this case, 68. So I have 51 over 68. Now I'm not going to spend the time to do a long division problem here. So what I will do is I will break out a calculator. Here's one that hopefully will show up on screen. And let's clear things. So this is a fractions of division problem. So I'm going to do 51 divided by 68. And that gives me, oh, look at how nice and round that's a pleasant number, isn't it? So this equals 0 and 75 hundredths. So we have a lovely decimal here. And in order to go from decimal to percent, we shift the place value twice to the right. Sometimes you see people doing that. So in our case, it was here. It's going to go once, twice. It's going to end up there. And so we have a 75% increase. And we're almost done here. So what are we saying? We're saying that the price, we're saying the shoe price increased 75% compared to what the store paid. Let's verify that. Look at the problem. So a popular brand of running shoes costs a local store $68 for each pair. And they ask if the store sells it for $119, what is the percent increase in the price? So we did the calculation, that was a 75% increase. That means the store raised the price by 75% of what they paid for it. And that is it. So I don't know if that's what stores normally do, but in this case, that's what they did. So a little wrap up to where we've been, and then you guys will move on and you'll dominate this stuff for yourself. We did what is percent change. It's this ratio of the change over the starting value written as a percent. And it's made up those parts, the change and the starting value. We practiced calculating some examples, remembering the example we have from class. And we did one problem from, a problem from the homework, and we thought about the answers. You know, when you think about the answers, what you want to do is you take a look at your answer, and you think about it in terms of the original problem. So what does this 75% have? And what does it have to do with this problem? The 60% I got right here, what does it have to do with this problem here of how much the flour changed by? Hope this video helps. You guys have a great evening. Let me know if this video was useful.